The EM sensor works on the fundamental of the electromagnetic property of the steel is changing when the microstructure is changing. So the fundamental science is there, and the next step is to actually make the sensor and put the sensor into the industrial environment, such as a run-out table at the industrial mill. Within the task 8, we have actually designed and made sensor heads that are going to be installed into the steel manufacturers. Microstructure is absolutely the key to any mechanical properties or other properties that the steel grade is needed. Metallurgists and steel makers are controlling the microstructure to achieve those properties. What happens is you tend to make the steel first, and then you check the microstructure and its property afterwards in a destructive way. So you have to cut the sample out and do the microscopy to look at the microstructure. Two things about that. One is you get one representation place for the whole coil. So if you take a measurement at the front of the coil, it kind of represents the whole coil length. Whereas if you have a in situ measurement of the microstructure, then you get a sense of uniformity of the product. After the steel is being processed, you then get a test that the process is already been complete. So there's not much you can do with it rather than, melt it or reheat it and reprocess it. Where if it's an online in situ measurement, then there is opportunity to feed back that signal to the processing parameters and be able to then change and optimize the process for this steel grade. What we have got here in WMG is a furnace and run-out table set. We are kind of simulating what the industrial environment are. So the fact that we have a furnace, so anything come out of the furnace is representing their hot rolling strip is coming out from their furnace and then coming onto a run-out table where you can apply cooling. So if you apply different cooling methods such as air cool or water cool, then you can get different cooling rate, and that will change the transformation rate, meaning the microstructural changes. For us, it's very important to understand how does each different microstructure features affect the magnetic signals. And the fundamental for that is to model and understanding how each of the microstructure features is going to impact the magnetic domain wall movement. We have carried out some micromagnetic model. We have done some FE model relating microstructure and EM signals. And we have also been doing experimental study to look at how domain walls physically interact with microstructure pinning.